Okay, so we can continue with the next block of sessions, and the first speaker will be XForms man. Oh, sorry, Stephen Pemberton.
How about that? Yeah, that's better. Okay. Good. To your great surprise, I'm going to be talking about XForms this morning. The basic story is about a future implementation being created by Alain Couthures. He's the man behind XSLTForms. He's creating a new version, and so I'm giving a little background to some elements of that. I guess you all know what XForms is in worldwide use, and we have lots of evidence to show that using XForms reduces application development time to about a tenth, and we have that on the basis of some very large projects that took years. So just to give you also, I mean, most of you know about XForms, but of course this is being streamed live as well. So just to give some background to XForms, XForms programs are divided into two. In the same way that HTML has content and style, XForms programs are divided into the data part and the content part, which displays the values from the data part. And of course, that gives similar sorts of advantages to how style works in HTML or with XML, of course. That separation has a lot of advantages. So the model part, which is where the data is stored, you can have any number of instances. Those instances can have data coming from external sources. It can be a file, as it were. It can be any URL. Or you can have inline data within the model. Then you can attach properties to the data, and the fact that the data is coming from outside and not necessarily under your control, you do this separately from the data itself, so you do it by binding to values within the data. The ref part is any XPath, so you can just use XPath to values there, expressions there, to select parts of the data, and then you can apply certain properties to it. So I just go through those properties, at least the properties that are of interest for what I'm going to be talking about later. So types, although you can also assign those with schemas. Relevance conditions, so that's saying under what conditions certain data is relevant, is useful, is necessary. If it's not relevant, then when you submit the data back, the data is not necessarily included with what you submit back. Required and optional, so that is to say whether that piece of data is required before you can submit. If that hasn't yet been filled in, then you can't submit the data back to any other place. So, for instance, you could say the postcode is always required in an address, but you could say that the state is only required if the country is USA. Read-only conditions. Again, you might say that the order number which you've read in is read-only always, but you might allow the street to be changed under certain conditions. For instance, you might want to the street name might have been filled in automatically, but if you select manual, then you're allowed to change it. You can add extra constraints apart from types. So, for instance, you could, in this case, you can restrict the age to being within a certain range, or there are functions available. So, a credit card, you can apply the function that tells you whether a credit card number is actually a valid number, so that you can check that it's actually correct. You'll see a lot of these in working in a moment. And finally, calculations. You can calculate values based on other sets of values. So, for instance, the total can be the sum of the individual items. or the tax can be the total sum times the tax rate, and so on, just like in spreadsheets. So that's the data part, the model part, and then the content part contains controls. Here are some examples. You can output, you can input a value, you can select a value from a number of options. All controls have a similar sort of style. They all have labels. They all have, you can add hints, so that if you hover over it, you get a hint about what's being asked for. You can have alerts that's the message if the value doesn't satisfy its type or its constraints. So they bind all the controls, and that was just 3 examples, all the controls bind to values in instances. And the controls are unusual for this sort of application in that they're not visually oriented. They're designed to specify their intent. So it tells you that select one says you're selecting a value from a number of values, but it doesn't require that to be represented in any particular sort of way. So the controls say what they do, but not how they do it. And that leaves visual requirements over to styling in particular. So the result of this is that controls are device and modality independent and also very accessible, so that you can create a speech browser for blind people, and they know what the controls are trying to achieve without having to try using heuristics to work out what's actually being represented there. So an implementation has quite a lot of freedom in what it can do with controls. Now, this also means that the same control can have different representations depending on the device or the modality. So it's thanks to this freedom that implementations can and sometimes must, according to the specification, take those properties of the data into account in deciding how to represent them on the screen. And relevance is really the biggest one in this case, because, and actually demanded by the language, because if a value is not relevant and a control is bound to it, then that control is not visible, not displayed, at least by default. Most properties, type doesn't, for instance, but most of them depend on a Boolean expression, so that it says under what conditions that property holds. So the property can change at runtime, so the control has to be ready for those changes. So for instance, here, a bit of an application for taking a payment, so you can select the payment type and then input the credit card number. But the credit card, as you saw in the earlier slide, the credit card number is only relevant if the payment type is credit. So if I say I'm going to pay by cash, then nothing happens. But if I say I'm going to pay by credit card, then up pops the control. That value becomes relevant, and so the control has to be visible. There's another sort of relevance as well, and that's whether the data actually contains the value that you're binding to. You can add bindings to data that's actually not in the data. So this is good when it's coming from external sources where certain fields may be optional. But of course, that data element might later come into the data. It might be inserted. For instance, here I insert the element that this control is bound to, and so the control has to emerge. And if then I delete that element from the data, then the control disappears. Types are a good example of how an implementation can adapt a control to the type. So these 4 controls here, so they're just referring to items in the instance, and you can't see any difference in the controls, but the implementation knows the types of them, so can do different things with them. So here it knows it's an integer, so it's going to start from the other side. This is a Boolean, so it's just a simple checkbox. And finally, a date allows me to pop up a date picker. And all of these, of course, also include validation checking, and so let you know when the data is not correct. Other properties don't affect the form of the control, but can affect styling. So for instance, if a control is bound to a required value, then the implementation is at liberty to choose how it indicates that to the user. So here's an example of filling in an address. We've said that the state is required when the country is USA. Well, there is a state called North Holland in the Netherlands, but you don't normally put that into an address. But as soon as we choose the USA, then up pops the indication that the field is required. And if I delete it, then all of a sudden it says, oh, well, it's not valid because you haven't supplied that value. But there's nothing in the content that says that that's happening. This is all happening by the implementation under control of the style sheet. Similarly, read-only. If a value is read-only and it's connected to a control, in this case, an input control to a read-only value, then the implementation should make it clear to the user that that's not an editable value. So if I go here, there's nothing, I can't select it, I can't edit. But if I change that value there to say, oh, well, I want to edit it, then I can go in, make the change, and then make it read-only again. So for validity, so that's type validity and connection to a constraint property, the control can and should indicate the validity either positively or negatively. Usually it will happen negatively. That's to say you'll get some sort of error indication if you've done something wrong. But it's also possible that you get a tick to say, yes, this is okay. So for instance, well, you've already seen that with numbers. So that's a type problem. I think I also did it with a date. So I select a date and then change that. And a credit card, well, I happen to know that this is a correct credit card number, but if I change that to a 2, then it says this is not a valid credit card number, and that's because it's used the alert information within the control. Okay, so implementing this, XForms was explicitly designed for different implementation approaches, so that it wasn't meant to be either client or server, but anything could happen. So there are native implementations where the XForm is directly served to a client that processes it directly. The server-side implementations where the server looks at the device that's asking for the form, looks at the device and works out what it can accept, and then compiles it down to that form to a form that it can use. That may require then some communication between the device and the server while it's busy to achieve some of the functionality. If for a small device, for instance, that doesn't have many possibilities, and of course you can do some hybrid combination of both of those. So the implementation I'm talking about today, Alain Couthures is the person producing it. Unfortunately, he couldn't be here this week. So XSLTForms is a client-side implementation, and it works by sending the form to the device and using XSLT to transform it on the device from the XForm into a combination of HTML and JavaScript. So that all processing takes place on the client. The nice thing about this over a pure server-side implementation is that if you do a view source, you actually see the XForm as it's written and not the transformation. Whereas a server-side implementation will send something down. If you do view source, you'll only see the transformation. So this means that, of course, you have to design the transformations from the XForm into equivalent HTML plus JavaScript. And since the controls in XForms contain a lot of implicit functionality, the transformations actually, even apparently simple cases, can be quite complex. So let's just take one of the simpler examples. So here, we're inputting the credit card. It's got a label and it's got an alert in the case that it's not valid. And you get this HTML as a result. It's quite hairy in a way. What you see from this is that each part of the original is represented by spans as subchildren of the main element. So the main element is the control, and then it's got different spans in the middle for representing different parts: the label, the value, the alert, and whether the things necessary for representing that it's required. What you also see is a lot of class values at the top there that says it's a control, that it's in particular an input control, that it's optional, the value is optional, the control is enabled, that the value is read-write, and that the value currently is valid. I've said all that. Oh yeah, and of course those last four, that it's optional, not required, enabled, rewrite, and valid, they all depend on Boolean values in principle, and so they can change during runtime. For instance, XForms valids can become XForms invalid as a class. Now, the nice thing about the combination of HTML and CSS is that a lot of the work can be left over, can be given to the CSS. You've got all the power of CSS at your disposal. And in particular, it can use those class values we just saw to affect the presentation. So the most obvious case is when a value becomes non-relevant, that we can just do display none. So in other words, it just disappears from the screen. And Svante yesterday complained about the fact that you could have a style attribute on the head of HTML. Where is Svante? Oh, okay. Well, the reason is that the HTML head is just display none, and so there's no reason why you couldn't make the HTML head display block and look what's in the head. But anyway, but back to my talk. So you could just use CSS to make the controls disappear when they're no longer relevant. In fact, because of the CSS cascading rules, you should use important on that to make sure that it always does really disappear. So the transformation contains an element for when the value is required. It contains what it calls the required icon, which is an asterisk. So the default is obviously not to display it, display none, but if the control has XForms required on it, then that required icon then gets displayed inline, margin left, color red, and so on. And so in that case, you get this control here, you get an asterisk after it. Similarly for validity, there's an element, a sub-element of the control that contains information about what to do with when it's invalid. Again, it contains space for an icon, which in this case, the CSS just does a background image. And it contains the text for the alert. And again, the default is for not to display it, except when XForms invalid, when the controller's got the class XForms invalid, in which case you can display it inline with an image. And again, using CSS properties, and this is how it's done now, using CSS properties, if you hover over that invalid symbol, you get the message that tells you what's wrong with it. So for the coming new version, we're working on a number of improvements. Firstly, in the visual approach, a lot of people complain that XSLTForms is not very beautiful in its default style sheet, which I would agree with. So we want to fix that. And we also want to fix, do something about the transformed HTML. So the aim is to make it more attractive and more flexible. This is all work in progress. The first beta of this just got released this week. So for a start, in the original version, actually labels were just put in regular text next to the control, so controls just didn't line up. So the default style will be to do it in bold above the control, so that then all controls at least will line up on the left-hand side. This is very simple, just using CSS, font weight bold, and display as a block. Required, we don't actually need an element within the transformation to hold the icon, because CSS allows you to insert content. So we can get rid of that sub-element, and so when it becomes required, then we just add that asterisk after the label, as in this example here. So that simplifies the future transformed HTML. Similarly with invalid, again, we don't have to include an element for the icon at least, because we can just insert it with content, the content property of CSS. What this does mean, though, is that if it's both required and invalid, then we have to insert an extra rule, which we didn't have to do beforehand, because of the way cascading works, so that we actually have to recognize the case of a control being required and invalid. One other thing we're doing, which you saw in some of those examples, is that the background color of the control is going to be a light red as well, to make it clearer when something's wrong. And finally, for invalid values, we need to display the alert text that has still got to be there as a sub-element. We don't need the alert icon, but we do need the alert text, so that's in an element somewhere. And so normally that's not displayed unless it's invalid, and then we can pop up the text. So now, rather than hovering it, actually the text just actually occurs. So this is now a live XForm. Now, we want to add a bit of flexibility to styling. That is to say, some people might prefer their labels to the left. And because of CSS, you can add that flexibility. You could have display as inline block instead, so that the labels came to the left rather than over the top. And in fact, although CSS is not very good at reordering content, you can position the labels at different locations. Left, top, right, and with care bottom. So what we're proposing is to use a skinning technique, where at the top level you say where you would like to have your labels, and then we just have different rules for if you said labels top or labels left, and you get those automatically without having to know how CSS works. This gives you extra flexibility, because it means that you could have some groups of controls with labels left and some groups of controls with labels right. So here's just a demonstration of this working. Here's the labels at the top. Here are the labels at the left. So, and at the right, I'm not going to show you bottom because I haven't got it working properly yet, and it's very ugly. But at least you have complete freedom now about where the labels appear without actually having to do any work. You just put it in the skinning class at the top. So HTML5 has apparently discovered XML, or at least a variant of XML, because you can now define custom elements within HTML5. They're slowly discovering the advantages of XML. These custom elements don't offer any additional functionality, but we can transform them to them so that the transformed HTML looks much more like the original XForms. It actually also greatly simplifies the XSLT necessary to do this transformation. It's currently 10 times smaller than the original XSLT. So for instance, now the input command now looks like this, an XForms input with XFref, credit card, and so on. It looks very close to the XForms, so it makes it much easier to see what's happened. And you can use the same CSS techniques that I've just described. So XForms offers a lot of flexibility in how it can be implemented. One of the advantages of transforming to HTML, it means that you've got the power of CSS. To avoid the XForms programmer having to know anything about CSS, skinning techniques can be used to offer flexibility in the representation and presentation of controls. The new XForms implementation is in preparation. It will use these techniques, and hopefully by the summer it'll be complete. Thank you very much.
So we have time for questions. Anyone?
Thank you very much. The last commit to the XSLTForms repo in the only branch was from October 2018. Can you tell us something about the availability of updated tools?
He changed the place where he changed the place where he changed the place where he kept the sources, and I don't remember where it is because I always just get it directly from him, so I don't. Well, there's a mailing list, and it'll be clear from that.
Thank you.
All right.
Some more questions?
Okay.
No?
Thanks very much.
Thank you again.